Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome to today's POTD session, and I am very pleased to see you all here. So, before we move ahead, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? All right, hi Rishit. If All right, thank you, Hariom, for the confirmation and welcome to the session. Thanks, Rishit. Thanks, Sagar. All right, so let's just wait for a couple more minutes, all right, so that rest of our friends also join. Until then, all of you can quickly post in the chat section how many of you were able to solve today's POTD. Okay, let's just. No one in the chat section? All right, so no worries. We are going to discuss the question, and I hope it will be clear to all of you that how we can approach this question. So let us start with the question statement first of all. The statement reads as the task is to find the second smallest number with the given sum of digits as s and the number of digits as d. So, like there are two values that are given to us. In input, we are provided with s, that is the sum of the digits, and the second value that we are provided with is d, that is the number of digits. All right. So, the output that we are getting here is 27. Let us first try to understand the example. So, in the first example, the sum of the digits given to us is 9, and the number of digits that is given to us is 2, right? So as you will see, the first digit that we can get with these properties, okay, so, all right. Okay, so the sum that is given to us is 9 and the number of digits that is given to us is 2. Okay, so the first number that we are going to get by following these two characteristics, that is 18, the number of digits is 2 and the sum of the digit in is 1 plus 8, that is 9. Okay, but we need the second number, right? So the second number that we are going to get, that is 27, that is 2 plus 7. Okay, it will give us 9. So that is the answer to this question. You need to return an integer, right? Yeah, and actually that's in a string form, right? So you need to return it in that way only. You need to return the answer in the string format, right? So now let us see how we can approach the question. So basically the intuition behind this question is, like, let us say that first of all we will try to find out the first minimum number, okay, which follow the criterias, right? Now, once we have that first minimum number, what we can do is with the help of this first minimum number, we can move to our second minimum number, right? All right, so as the question statement demands us is that the second smallest number we need to find out. Okay, so once we have found out the first smallest number, we can easily find out the second smallest number. Now, how we can achieve that? Let us say, all right, guys, if there is any confusion, please feel free to post it in the chat section. Okay. All right. So let us say the string that is given to us is 107. 99. Okay, this is the first number. Let us say this is the first minimum number. Okay, now if you want to jump to the second minimum, in which the number of digits is same and the sum of the digits is also same, so in that case what we need to do is, whatever the first digit is there, okay, which is less than 9, you simply need to increment it by 1. All right, and the next digit to it, you simply need to decrement it by 1. Okay, now why we are decrementing it by 1? So that the sum must remain same. Okay, you know, in any integer, if you do +1 and -1, the resultant effect will be 0, right? So what we need to do is, whatever the first integer is there, right, which is less than 9, simply increment it by 1, and the integer, the digit that is next to it, decrement it by 1. Okay, so in this way the sum will remain intact as it is, and the number of digits will also be the same. Okay, so the here we will be getting our output as 10889. All right, so that is the answer to this question. All right, so okay, I will explain the question once again. So basically the question statement reads as, we need to find out the second smallest number. Okay, now what is that second smallest number? There are certain conditions. For that number, the number of digits must be d and the sum of the digits must be s. Okay, so after following these two conditions, you need to find out the second smallest number. So till now I explained that when we are finding the second smallest number, what we can do is, we can first find the first smallest number, and then from there we can jump to the second smallest number. Okay, so, all right. Now, see, first of all, the brute force approach, that is very simple. What we can do is, we can simply iterate through all the integers, right? And we can check this condition, if this condition is getting verified or not. And if that condition is getting verified, we can return that integer. Okay. So that is the brute force approach. And but if you will see in the question, the expected time complexity that we have here is big O of d, right? So we, rather than iterating over all the integers, we need to have an optimized approach. So, okay, let us see how we can have an optimized approach. All right. So here we are discussing optimized approach. Okay. So, okay, everyone tell me, see, there are certain conditions in which there will be not any possibility of forming a number whose number of digits is d and the sum of the digits is s. Okay, there are certain conditions in which this will not be possible. All right, so if any one of you would like to mention those conditions, any idea, anyone? What could be those conditions under which it is not possible to form the required number? Just think about it. Like, let us say if I want to have a two-digit number, and if I will say that the sum of the digit must be, say, 20. Is this possible to have a two-digit number with the sum as 20? Any two-digit number whose sum can be 20? Exactly, Rishit. That's very much correct. The first condition that we have here is that if the sum of the digit that is greater than or is equal to, okay. All right. So if a sum is greater than or is equal to 9 into d, right? So in that case, it will not be possible for us to form the digit, right? So this is the first condition. Now, what could be the second condition? My screen is visible, guys, right? Yeah, why the equality, Rishit? That I shall be explaining towards the end of the question, okay? Because, okay, let me explain it now only. Okay, let us say we have said that we want a two-digit number whose sum is 18. Okay. Now tell me one thing. If the digit that is given to you is 99, okay, this is the first smallest number whose sum can be 18, right? Is it possible to form a second smallest number whose sum can be 18? You can't form, right? Because this has exhausted it, right? If greater than number like greater than 99, see, whatever will be the second smallest number, yeah, whatever will be the second smallest number, that is for sure that it is greater than the first smallest number. right? So greater than 99, we have 3 digits number. Okay, so in that way, it will not be possible for us to form a 2 digit number whose sum can be 18. So that's why this equality sign, right? And that was a good question. All right, now what could be the other conditions in which it will not be possible for us to form the integer? Okay, let us say if there is a condition that says that if sum of the digits is equal to 1, in that case, can you find the second smallest number whose sum can be 1? Like there is only one digit whose sum is 1, right? So that's why this can be the other case. Is this case clear to everyone? Let me know in the chat section. Like why s is equal to 1. And next thing, if the number of digits, yeah. So if the number of digits that is also equal to 1. So in all the three conditions, it will not be possible for us to form the answer, right? So if any of these conditions exist, so we can simply return -1 because it means that string is not existing, right? So these are the three conditions that you can say that is a checking condition, okay? So if any of these conditions is getting validated, you don't need to execute the program further, right? So we are clear here. Now let us move to our next part. Okay. So basically what we are doing is the smallest number for every digit, okay? Like say we have 2 digit number, we have 3 digit number, right? We have 4 digit number. So what is the first digit of the smallest number? What is the smallest 2 digit number? Yeah, actually, Rishit, that can be another condition, but if you will look at the problem statement, it is mentioned there the constraints for the sum and the number of digits is starting from 1 only, right? So you will always have the values greater than or equal to 1. All right, guys. So, yeah, can you tell me what is the smallest 2 digit number, 3 digit number, 4 digit number, and so on? 10, exactly. The smallest 2 digit number is 10, the smallest 3 digit number is 100, the smallest 4 digit number is 1000, and so on. So, we noticed that the smallest number in each of these cases always starts from 1. Is this clear? That the smallest number always begins with 1, right? So, as here we are required to find the minimum number, so our first target will be, or like what we are aiming at to find integers which starts with 1. Okay, is this question clear to you all? We are aiming at finding integers which starts with 1 because only in that case we can have the smallest number. Because all the smallest integers values, the least possible value that they can have is if they start with 1. Okay, is this clear? Okay, so I hope it is clear. So what we will do is that we have already fixed that, let us say the number of digit is D. Okay, this, let us say this is D, whatever it is. So what if we are doing is we have already fixed here that the first digit is going to be 1 always. Okay, so that we have fixed, right? So now everyone tell me, if the first digit we have already fixed, so now can I subtract 1 from my sum? Because in the sum of the digits 1 I have already taken, right? So I can now subtract 1 from the sum. This can be done, right? Yes, okay. Right. Now, what we are going to do is, let us say my string is going to contain the answer, that is the string ans. Let us say it is empty for now, okay. So what I will do is, I will start the iteration from the end, right? And towards the end, what I will be doing is, whatever value that I'll get. Okay, like let us say if my sum is say 17. Okay, so what I'll do, 17 is greater than 9, I will insert 9 here. Okay, now 17 minus 9 will give us what? 8, right? Yeah, 8. So it will give me 8. So I will insert 8 here. Now how much is remaining? 9, 8, 17. Okay. So now we have completed the sum value, right? So what we will do is we will start the iteration towards the end. Okay. Like let us say from this position, and we will keep on filling this position until and unless the sum is greater than is equal to 9. Okay. So till that point, what you need to do is you need to keep on fill the position. Okay. And then also decrement that integer value from the sum. Okay. Like let us say if you will start filling it, let us say the sum of the digits they have, this is 1 2 3 4 5, so 45, it should be less than 4. Let us say it is 30, right? So 30 is greater than 9. Yes, so I will simply add 9 here, right? So 30 minus 9 is 21, so 21 is again greater than 9, so I will simply add 9 here. Okay, so 21 minus 9 will, okay, right? So in that case you can keep on filling up. Okay, and in any case, let us say if the sum has become 0 but you have not iterated till the last index, then what you can do is you can simply fill the 0 there. Okay, why 0? Okay, that is safe to put the 0 there because you have already exhausted the sum value, right? So you can keep 0 there, and at the end when you have completely filled it, what you need to do is you need to simply add 1 at the end. Okay, because as we saw there, you can simply add 1. Okay, because as we saw there, what is happening is that the smallest number always starts from 1. Okay, smallest number starts with 1, and actually this 0 wala case is not going to come because we have already taken that base condition in the consideration, that sum is always going to be greater, sorry, smaller than is equal to d into 9, so there won't be a case when it is coming to be 0. All right, so at the end you simply need to write 1, and then when all of these thing is done, all the operations are done, simply reverse your string. Okay, let us say when you were fulfilling your strings, the value that you were getting is, let us say you have filled it 9970, and at the end you have added 1. Okay, sorry, 99701, yeah. So at the end you have added 1. Now what you need to do is you need to simply reverse it, right? So if you will reverse it, you will get it 10799, which is of course the smallest integer that you can get. Okay, and the sum is 9 10 17 18 19 20 21 22 23 24 25 26. The sum is 26. Okay, so this is the thing, like if I write down the step, it is decrement value of sum by 1, start iterating from end. Why I'm iterating from end? Because the endpoint contains the like start the iteration from the rightmost because it contains the least significant value. Okay, start iteration from end, keep on adding the integers according to the condition. Okay, keep adding integers, and then once all the integers have been added, add 1 at the end, and then what you can do after that, simply reverse it. All right, so for the intuition, the intuitions that we had for this question is, the first question, the first part was that it needed us to find the second smallest, right? So if you are finding out the second smallest, it is very obvious that you will need to pass out through the first smallest, right? You will need to go through this element. So basically here we focused on finding out the first smallest integer, right? Now to find the first smallest integer, it was very clearly visible to us that all the smallest integers starts with the value 1, right? Only in that case they can have a least value. So we tried to form an integer, okay, whose sum is less, like we have decremented the value of sum by 1 because 1 we have already inserted here. Then we tried to form an integer, we inserted the value, okay, in such a way that whose like as long as the sum is greater than 9, you can keep on inserting 9, or then you can keep on inserting the smaller digits than it, okay, according to the conditions. And then once when that string is formed, you need to reverse it. Why reverse? Because in this string you have added 1 at the end, okay, but we need to find the smallest integer, so that's why you need to add 1 at the beginning. Okay, in that case only you can get the smallest integer. So basically the intuition was first of all to find the first smallest, and to get the first smallest integer, what we can do is form the number which starts with 1. Okay, so form the number which starts with 1, whose sum is 1 less than the required sum and the number of digits is same. Okay, so this was the intuition, and for that we have used that approach. Now once you have done all these two things, then what you need to do, as I explained in the beginning of the session, if it is, let us say, 10799, okay, this is the first smallest. Now we need to go to the second smallest. For that it is very easy. What you need to do is you simply need to increment this value by 1 and decrement this value by minus 1. Okay, now why we are doing this? Whatever the first integer that you are getting that is smaller than 9, simply increment its value by 1. Like, okay, so all those conditions were being taken care of, the three base conditions that we are checking here. Okay, like if sum is greater than is equal to d into 9, okay, in that case it was getting covered, so number of digits is not going to get exceeded, right? So what you need to do is simply do plus 1 and here simply do minus 1, and after doing these two operation, what you will get? You will get 10889, which is definitely the integer which is greater than this. The sum is same, the number of digits is same, and it is the second smallest number that you can have, right? So this was the approach that we used for the question. And now let me share the code. So yeah, this is the code. Okay, you can look at the code of the question and you can let me know if there is any part that is not understandable by you. I'll make it understand. So we have, all right, so okay, let me explain one thing. uh, this is our string, right? Answer. So when you were adding the elements, what you are doing is you are, okay, so when we are fitting my answer string, when I'm inserting the integers inside the answer string, in that way, like although I'm starting the iteration from the end, okay, so that iteration is for the number of digits, right? That how many digits are we need to frame. But when you will add it inside the answer, first of all 9 will be getting added, okay, then again 9 will be getting added, then 7 will be getting added, then 0 will be getting added, like that, okay, and at the end we are adding 1. So what will happen that if you will reverse it, the most significant digit will get positioned at the least significant position, right? So in that way you will be able to get the like the integer with the 1 will be placed at the most significant position, so in that way you can get the smallest number, right? Like don't get confused by it. The iteration we are starting from d minus 1, that is for the number of digits, that how many digits we need to have, like how many position we need to fill, okay. But inside our answer string, what is happening, that the highest value, that is 9, okay, that is getting filled at the most significant position. So after that what will happen, that when you will reverse it, it will get shifted to the least significant position, okay. Okay, so as you mentioned, if sum is 20 and d we have is 3, okay. So first of all, we'll decrement the sum by 1. Okay, so we are getting it as 19. You can simply add it here. Now, if you will start it by here, 19 is greater than 9, of course. So we can put 9 here, okay. Now, if I will decrement the 9, I'll be getting 10. So if sum we need to have 20 and 9, 10. Is it possible to have some 20? Let us see what is the answer that we are getting for 20. Okay, is the code screen visible? Yeah. So if I write for the custom input, and as you mentioned, the number of digits S is 20, base 3. Okay. And when I will do the compile and run, yeah, in that case, okay, so okay, I got your problem. So basically, we were mentioning that at the end of every one, we are adding 0 s plus 1, right? So all right, in that case, if all the positions will get fulfilled by it, then in that case, at the end, this one will not be getting added. Okay, if all the positions are getting fulfilled, so what we are doing here is rather than initially adding one here, you can simply add it as 992. Okay, it will be getting added like that. It is not necessarily that you need to add one at the end. You can decrement the value of sum by 1 because to be on the safer side, we are keeping it in the account that just in case, like let us say if the digits are remaining, okay, and if the sum got exhausted, and if you are placing 0 here, okay, so it will become an invalid integer because if any integer will start from 0, so it will become an invalid. So what you need to do is you need to add 1 at the end just to be on the safer side, okay. And in case if you haven't reached till this point, if none of the digits is 0, right, like if none of the digits has been framed at 0 and if all the digits are getting filled, then in that case it is not required to fill the 1 here, okay. So when you will reverse this, you will get 299, and after doing this incrementing and decrementing procedure, you will get 389, right? So like the first digit that is smaller than 9 is 2. So I have incremented it by 1 and I have decremented the 9 by 1. So I got 389, right? So that is just that so that integer cannot be invalid. Okay. So if any integer will start like let us say all the positions are fulfilled. Okay. 9, 9. Okay. Let us say the sum was 18 and the number of digits was 4. So in that case, this 99 will fulfill the places. So what we need to do with this remaining places, right? So in that case, fill the remaining places with 0. Let us say the number of digits is 5. Okay. So in that case, fill the remaining places with 0. And that's why we have added 1 at the end. Okay. All right. So as I was saying, yeah. Yes, I'm explaining it in note only. Like, see, what we have done here is like, let us say I have the number of digits as 5 and the sum of digits as 18, right? So in that case 1 2 3 4 5, in that case if you will fill the 9 and 9 here, okay, so in that case what will happen is that you have to fill these places with 0. But if you will reverse it, okay, so if any integer is starting with 0, then that will be an invalid integer, right? So that's why we are adding 1 at the end so that integer will not become invalid in these kind of cases, right? And if anyways, if just after by filling all the digits you are getting the final answer, like when you have decremented the value of sum by 1, and in that case you are able to fulfill all the places, right? So in that case you don't need to add a 1 at the end, okay. In that case you can simply reverse your string and you can do that increment and decrement thing. So after reversing, I'm getting 299, right? And in this 299, the first value that is less than 9 is 2. So increment it by 1 and then decrement the next value by 1. Okay. This will be as it is. So I'm getting 389. Right. Now let me share the code. Alright guys, so this is the code. If at any line there is any confusion, please feel free to ask. I hope that part was clear to you all, okay? Like as you saw here, when we are iterating the loop, we are iterating the loop from d minus 1 and we are iterating it till only one position, okay? The 0th position, okay, the number of digit, this last place we are keeping vacant, okay? We will either replace it with 1 or we will either replace it with s plus 1, depending upon the requirements, right? So that last index we are keeping a blank, okay? As you can see in the question, like as you can see in the code as well, we are iterating the loop from d minus 1 and I is only greater than 0. So keep that in mind, okay? So as you can see at the end, we are we are adding s plus 1. So if sum has become 0, you can simply add 0 plus 1, that will be 1. But if the sum is not 0, then you can do that s plus 1, okay? So in that case, you will be getting your answer. And also let me share the code for this question. Alright, guys. So in the chat section, I have posted the ID link for the code for this question. Okay, and this is the question. If there is any doubt, please feel free to ask. Yes, S might be positive. That is not necessary. So that's why if at any point of time S is becoming smaller than 9, we are updating its value with 0. Okay, because we don't want negative values. So that's why when you will add 0 plus 1 at the end, you will always end up adding 1 at the end. Okay. So that will give you a valid answer. So like these are certain base conditions, that you always need to keep in mind. Okay, so is everyone clear about this question of today's? Please give me a +1 in the chat section. Or if there is any doubt, please feel free to ask. I have shared the link. And also don't. Okay, why S is equal to 0? Because let us say the sum was 9, right? And like let us say if sum is greater than 9, and if you are subtracting 9, like if you have added all the values towards your sum, okay. Uh, yeah. So let us say my sum was 17, right? Here I have added 9, here I have added 8. Now what do I need to add at these places? In these places, like if you will do sum minus 17, initially sum was 17, okay? Why S minus S? You need to subtract the integers that you are adding, right? Because at the end you need to find out the sum of the digits, right? So you need to subtract the digits that you have added. First of all, you will do 17 minus 9, okay? Then this minus 8 and so on. You need to subtract the digits because we are finding sum of the digits, okay? Actually, that condition that you are showing, that S minus is equal to S, that is basically, S is equal to S minus S. So that is, yeah, of course, we can discuss the space complexity and time complexity. So as we can see here, we haven't used any additional space, right? So the space complexity is going to be the constant, and the additional space is not used, and the time complexity, that is going to be big O of D, right? Because the maximum iteration that we have done is only for the length D. Okay, it's not for the length n or the number of integers that we have. So the space complexity is big O of 1 and time complexity is big O of D. Okay, everyone. So all right, guys. Are we good with this question now? I hope this was clear to you all. No, Lalit, actually S minus is equal to S is not a correct expression in itself. It will not evaluate to the correct answer. So you should not use it. Okay. So I hope we are clear with this question. If we don't have any doubts in the chat section, I don't see anything there. All right, guys. Thank you so much for attending the session. I hope I was able to make the question clear to you all, and I have shared the question link as well. Keep on practicing. Keep solving POTDs. That will be very good for you. And yeah, bye. Good night, everyone. Take care.